In this video, I'm going to go over some examples of variation. First, let's recall what the definition of direct variation is. Y varies directly as x, or equivalently, y is directly proportional to x if there is a real number k called the constant of variation, or variation constant, such that y equals kx. So direct variation means we're dealing with the equation y equals kx. Let's look at the first example. If x varies directly as y, and x is 27 when y is 6, find x when y is 2. So x varies directly as y. This translates mathematically to saying y equals kx for some constant k. Next, x is 27 when y is 6, so we have 6 equals k times 27. But this allows us to solve for k. This means that k is 6 over 27, which simplifies to 2 over 9. We can update our equation to writing y equals 2 over 9 x. Now that we know that k is 2 over 9. What is the question asking? We want to find x. So what is x when y equals 2? When y equals 2, we have 2 equals 2 over 9 x, which means that x is 2 times 9 over 2, which is 9. Second example. For a given height, the area of a triangle varies directly as its base. Find the area of a triangle with base 8 feet if the area is 24 square feet when the base is 12 feet. So let's declare that A is the area, and let's say that B is the base of a triangle. They tell us that the area varies directly as its base, which translates mathematically to saying that A is equal to k times B for some constant k. Now we would like to know the area when the base is 8 feet, but unless we can find k first, we won't be able to do that. That's why they give us the information that the area is 24 square feet when the base is 12 feet. In other words, 24 is equal to k times 12, which allows us to solve for k to get k equals 24 over 12, which is 2. With that, we can update our variation equation to write A is equal to 2b. Now, what is the area when the base is 8 feet? Well, the area is 2 times 8, which is 16 square feet. Now let's generalize direct variation to direct variation as a power. We say that y varies directly as the nth power of x if there's a real number k such that y equals k times the nth power of x. Here's an example. For a body falling freely from rest, disregarding air resistance, the distance a body falls varies directly as the square of the time. If an object is dropped from the top of a tower 400 feet high and hits the ground 5 seconds later, how far did it fall the first 3 seconds? Let d denote the distance in feet and let t denote the time in seconds. What is the relationship between those two variables? Well, the problem tells us that the distance a body falls varies directly as the square of the time. This translates mathematically to d equals kt squared. Now, if an object is dropped from the top of a tower 400 feet high, it hits the ground 5 seconds later. So this means when d is 400, t is 5. They give us this information to find k. So we write 400 equals k times 5 squared, which means that k is 400 divided by 5 squared, which is 25. This means that k is 16. Let's update our variation equation to d equals 16t squared. The question asks, how far did the object fall the first 3 seconds? In other words, what is d when t is 3 seconds? Well, d is 16 times 3 squared. That's 16 times 9, which is 144 feet. Finally, let's talk about inverse variation. Say that y varies inversely as x, or y is inversely proportional to x if there is a real number k such that y equals k over x. More generally, y varies inversely as the nth power of x if there is a real number k such that y equals k over x to the power n. Let's look at an example. The unit cost of producing a phone charging device varies inversely as the number of units produced. If 10,000 units are produced, the cost is $2 per unit. Find the cost per unit to produce 25,000 units. So we write C is the cost per unit and let's say N is the number of units produced. What is the relationship between C and N? Well, the problem tells us that the unit cost of producing a phone charging device varies inversely as the number of units produced. This translates mathematically to C equals K over N for some constant K. When 10,000 units are produced, meaning when N is 10,000, we know that the cost per unit is $2. This information is useful for finding K. So we write $2 is equal to K over 10,000. which tells us that K is 20,000. Let's update our variation equation to C equals 20,000 divided by N. We would like to figure out the cost per unit to produce 25,000 units. Well, the cost is 20,000 divided by 25,000, which reduces to 4 over 5, or $0.8. That's, of course, equivalent to 80 cents. That's the cost per unit to produce 25,000 units.